In our previous lecture, we learned about z-scores and how to figure out a probability associated with a certain value. This lecture is going to go over the opposite. We're going to figure out how to find a certain x value associated with a probability. This is what's known as a percentile. A percentile is the value which is greater than a specified percent of the observational units. Now, you may have heard something like the top 10% or the bottom 10%. In general, think of a percentile as like the bottom. What percent of observations is the value you're interested in greater than? So the 90th percentile is greater than 90% of observations. The 50th percentile is greater than 50%. The 20th percentile is greater than 20%. Let's look at an example using IQ scores. So if we remember, the IQ test score distribution had a mean of 100 and standard deviation of 15. Imagine our goal is to find the 90th percentile for IQ scores. What value does someone or an observation need to be in order to do better than 90% of observations? In order to figure this out, we're going to have to go back to our normal distribution calculator. So when we look at this normal distribution calculator, we'll notice that the mean is 0 and the standard deviation is 1. And what we're now trying to do is find the 90th percentile. So now we have a certain probability that we're interested in, and we're trying to find the value associated with it. So what we're going to do is we're going to put the probability that we're interested in into this red box. This is saying, hey, what probability are you interested in? And once we hit enter, it's going to spit out the value that we're interested in. Now again, a percentile is the percent of observations that you're greater than. So what we're actually going to do is look for this opposite area. I'm going to put in 0.90. And what this is saying is the value, or the z-score, 1.28. And we know we're in our z-score world because we have a mean of 0 and standard deviation of 1. What this is saying is the z-score of 1.28 roughly is larger than all of this area, is larger than 90% of observations. If you want to think about it a different way, 90% of observations are less than 1.28. So we actually look for the less than area because it's saying 1.28 is greater than 90% of observations, or 90% of observations are less than 1.28. So it's two ways to think about the same side of the coin. But again, what we're going to do is hit less than actually to find our percentiles. 90% of observations are less than 1.28. So then the question we need to think of, okay, is how are we going to use this 1.28 to find the IQ score that we're interested in? Well, what we're going to do is this. We're going to turn our z-score into the value we're interested in. If we remember, a z-score says how many standard deviations away from the mean is the value you're interested in. Well, what we have, this 1.28, is the z-score associated with the 90th percentile. So we turn that percentile that we're interested in into a z-score. Then what we'll do is turn the z-score into the x value that we're interested in. We know the mean, we know the standard deviation, we found the z-score. The only remaining unknown value is x. And so if we were to reverse solve for x, we would find that x equals 119.2. So what this is saying is for people that have an 119.2 IQ score, those people did better than 90% of others. Or 90% of people did worse than 119.2. Now keep in mind, IQ scores are discrete. So nobody could have gotten 119.2. However, we are using a normal distribution to approximate probabilities and percentages. So we're not finding necessarily the exact percentiles or the exact area or the exact value, because we're using a continuous distribution to approximate a discrete variable. Now let's do this second example. Let's find the 10th percentile for IQ scores. So we're going to go back to our normal distribution calculator. And in this normal distribution calculator, the only thing we're going to change is that percentile that we're interested in. Instead of 90, we're now interested in 10%. And what we'll notice is we have a z-score of negative 1.28. So it was the same exact value as we saw for the 90th percentile, except now it's negative. And if we think about this, I'll go back and put 90. Think about how much area is to the right of 1.28. Well, there's 10% in this direction and 90% in the other direction. So when we flip this graph, we're going to be using the same exact value, except just on the other side of the graph. Now there's 10% in this direction, to the left, and 90% to the right. So we can see how z-scores work tandemly and are symmetric in that. So now what we'll do is this. We'll turn our z-score into the x value again. What we'll find is that if you have a z-score of negative 1.28, which represents the 10th percentile, that turns into a value of 80.8 for this IQ test score distribution. What it's saying is if you score an 80.8 on the IQ test, you did better than 10% of people, or 10% of people did worse than you. There are different types of areas that we may be interested in. So what I'm going to do is I'm going to do this maybe a little bit more complex example. Let's find the middle 50% of IQ scores fall between what two values? We'll go back to the normal distribution calculator. The normal distribution calculator is going to allow us to find what we'll call the central 50% of observations. So I'm going to turn this probability into 50% or 0.5. Now again, this was what a percentile is. It's saying the value of 0 is greater than 50% of observations, or 50% of observations are less than 0. That's not what we're after. We're after the central 50%. So I'm going to change this to this bottom option. And I'm going to type in 0.50. And what you'll notice, too much zeros there. What you'll notice is this red area is indicative of 50%. And these two blue lines are representing the values associated with that. Now this only gives you the positive version, but since our distribution is symmetric, we know this value is 0.6745 roughly, and therefore this value should be negative 0.6745. What's going on the right-hand side is exactly going on the left-hand side because of this symmetry. Also in the back of our heads, we should keep in mind that 25% of observations are less than negative 0.67. So if we were to look at negative 0.67 as a z-score, that would be indicative of the 25th percentile. This blue line is greater than 25% of observations. 25% are over here, 50% are in the middle, and 25% are above. If we wanted to talk about this value, positive 0.6745, well, this value is greater than this middle 50%, and it's also greater than this other 25%. So this blue line right here, this right blue line, the 0.67, is actually representing our 75th percentile, bigger than this 50% and that 25%. This blue line, the negative 0.67, is representing the 25th percentile. So when we look at the 25th percentile and the 75th percentile, that's giving us the central 50%. We can also think about this the other way. We could find the outside area. So notice when we change this outside area to 0.5, it's saying 25% is this way and 25% is that way, and we'll get the same exact value, 0.6745. This is giving you, this 0.5, the collective outside area, not the outside area on each tail of your graph. So whether I choose the inside or the outside, when we use 0.5, it's giving the same exact stuff. To find our actual IQ score values that we were interested in, what we would do is we would turn our two z-scores, 0.67 and negative 0.67, into x values using the z-score formula. Now, if we wanted to guess and check our answer, unfortunately, whether you're using the web version or the app version, if you wanted to change your mean and standard deviation to the values that you actually were interested in, it doesn't give you the between or the outside area options when you change your mean and standard deviation. So what we would do is we would find the percentiles that we talked about. We saw our lower percentile was 0.25. Right? That z-score of negative 0.67, if we turned it into an x value, we would end up with 89.88. So if you score 89.88, you did better than 25% of people, or 25% of people did worse than you. And if we remember, to get the central 50%, we looked at the 25th percentile and we looked at the 75th percentile. So if we were to change this to 75, that is giving us the x value associated with the z-score 0.67, or the 75th percentile. So these two values, 110.12 roughly, and 89.88, if we look at those two values, roughly 50% of people fall between those two IQ scores. So this is kind of a workaround, since this distribution calculator does not give you greater than or less than if you wanted to change your mean and standard deviation. However, I strongly suggest that we find things in terms of z-scores, because come a week or two from now, we won't be able to change our mean and standard deviation. We won't be able to do this. We'll only be able to think about things in terms of standardized values. So it's really good practice to try things in terms of z-scores, turn them into values that we're interested in, because we'll only be able to do that from a week or two from now.